Okay, I'm live. Hey, I was muted before, but I'm not muted now. Can you hear me? Okay, awesome. Let's wait for a few more minutes to see if other people are joining, and then we can get started. Hey everyone, uh, I'm Rahul. I graduated from Duke this year, and I currently work at this Y Combinator company called Cohere, which I helped co-found. Uh, so this talk will be about intro to React. Um, and we'll be going over some basic principles that govern React, and then we'll be building a simple app in two different ways. So we'll be working on a to-do list application without React, and then go through, and we'll do the same with React and see the difference, and we'll compare the code and see what the differences are. So to get started, I wanted to start off by talking about what React is. So React is a framework for front-end UI. So essentially, if you're looking for a backend framework, if you're trying to write like a machine learning model, like React's not the thing for you. Like React is just simply a way to express your UI elements. And there's several reasons why React is so successful. And if you look at any metrics over the past few years, React is just like one out compared to all the other popular front-end frameworks. And there's like various reasons why. Some of the reasons are because the modern web has become so complex and vast. There's a lot of complexity in modern web apps, and React is component-based. So essentially it helps you break down your code into several small pieces, and so that you can have break up your application into little pieces so you can have different people working on it and not like deal with complexity as well. The other thing is React is declarative. And so what that means is when you're expressing UI, you're not intentionally making changes. Instead, you're just writing function that takes in a state of your application and converts that into what your UI can look like. And this might sound confusing now, but we can go into more detail when I compare the two pieces of code that I will write live and show you. And this will be a live coding session, so feel free to ask me questions in the chat. Let me pull that up. Feel free to ask me questions in the chat, and I like to answer. If you have any questions, feel free to stop me anytime. Cool, so I'm gonna go ahead and share my screen. And I will be using CodePen for this presentation. CodePen's basically this really nice website where you can just start writing code. You don't have to like set up any dependencies or install a node or anything like that. And it also allows you to import pieces of code and libraries. And so it's a great way to be able to share small pieces of code with your friends. If you want to try something out or just like mess around, this is a great way. So we're going to build a to-do list application without React. And we're going to do it the hard way, do it the way before, like without React as the vanilla JS. And we're going to see how complex it gets as we add more complexity to the application. So to start off, we're going to add some HTML to start off like a base. So we're going to add a div. And we're going to say hi. So usually in HTML, you can create elements, and this you have a static website now. You can say hello world, and you have a static website, and you can just like publish to your web, and you have a little corner of the internet for yourself. But let's say we want to add some interactivity to this app, and usually the way you add interactivity is you add a script, and a script tag essentially lets you run JavaScript inside HTML, and so you could do cool things like document. So we're going to get a reference to the root. Okay. And so what this does, it gets a reference to this element, and then we can add things to it. So text content equals world. And if I run that, it becomes world instead, because when the code runs, first the root contains hello, and then when the script loads, it becomes world. So I'm going to move the script outside, actually. So the first part of this workshop, we're going to build a to-do list app. And so let's make a to-do list title starting off here. So title up there. And then we see a heading. And then we're also going to add an input where we can type items that we want, things we want to do, so that we can remember them. So we're going to have an input, and we're going to have a button. We'll say plus, so we know that it's an add button. And it should show up right here in just a sec. Cool. So we can also add a placeholder. So we could say something like buy eggs. So we know, so users know that they need to type in like sample to list items in here. And we would also want our actual to-do list items to pop up here. So we could have an unordered list in HTML, which is a UL tag, and also add list items. So cook food. Cool. So we have a basic to-do list UI set up. So this is the first part of building this. It doesn't do anything yet. So if I type in study for test and click the plus button. It doesn't quite work yet because we haven't hooked it up yet. So here's where the script comes in, because as a static site, it can't really do much unless you add some logic to it. And so we're going to move this and use the JavaScript feature, which uses a different file. So the first thing you'll notice is that we can't actually have any ordered list items inside the list yet because people haven't added it yet. So we're going to leave this empty and then give this element an ID so we can reference it later. And we can call it anything, but for the purpose of this one, I'm going to call it list items list. I'll just call it list. And so now in the JavaScript, let's obtain a reference to that element. So we can use the document.get. So we're going to so this function gets the reference to this element, and then I'm console.logging it just to see if it worked. Codepen also has a really nice console feature, so I'm going to grab that and see if it worked. Cool. All right, let's run it. All right, so we see that the console logged the list element, so we know that this code works correctly. So from here onwards, let's figure out what we need to do to get this working. So every time a user presses the plus button, we need to do a few things. So firstly, figure out what's the text that was typed into this input field, and then take that text and then create a new element, a list item in here inside the list, and then add the text inside that element. And because we're not using React, we have to do that all manually. So let's first obtain a reference to all the different elements we already have in here. So let's also get a reference to the button and also the input. So I'm going to call input this variable input. I'm going to copy paste, do the same thing. Okay, I'm going to assign IDs to this. So ID would be button, and so just give them names so we can reference them later. And it looks like let's also console log to make sure everything worked correctly. Cool. So it looks like all the elements are being logged correctly. So we see the list, we see the input, and we see the button. So the first thing is we have to add a click handler to the plus. So every time the plus is clicked, we want to do something. And in HTML, you would do that by adding an onClick attribute. So what that looks like is on the button, we can do the onClick and pass in a function. So set that to a function, and we can do console log button clicked. And so hopefully when we click the plus button, we should see the button string button click being printed to the console. So now we know that everything's hooked up correctly. And in this onClick method, we need to get the value of whatever is in the list first. So let's figure out how to do that. So we get the input, and then we get the value from const text equals input.value text. And so once that runs, type in something and then press the button, and it should log the text that was typed in. Let me check the chat to see if there's any questions. Wow, Rahul, you're a star. Thanks. Cool. So back to the onClick. So we're now figuring out how to get the value out of an input. And so it looks like if we do input.value, we can get whatever's inside. And so now let's make a list item that we can stick in the list. And use the value from the input and stick it in there. So to create a new element in HTML, you would use the document.create element. So let's make a new item, and let's call it create element li. And now there's a new element, a list item that lives in memory, and we haven't quite added it to the DOM yet. So we need to figure out where to put it in. So we're going to add it to list. So we do append child new item. And so every time the button is pressed, this code runs. So we first get the value from the input, which is here, and then we create an element, we create an li element, and then we add it to the list. So let's see if that works correctly first. So type in something here and add a plus, and you should add a list element. But you can see a bullet point, but you don't see a value, and that's because we haven't added the text from the input into the bullet point. So to do that, we would set the text content. So we would do new item dot text content equals text, and this should add the text to the list. Cool. So now that we've had this working, let's figure out how to clear this value, because ideally when your user is finished typing and press the plus button, they don't want the cooked food to still be in there. So let's clear out the input as well. So we could do input dot value equals empty string. All right, so cool. It looks like the value is being cleared. So we have a basic to-do list implemented, but this is a pretty bad to-do list because there's no way to mark if you're already done with something or if you would like to like remove something from the list. And this is where things get more and more complex. So as you can see, we have added, we've created one element and added it to the DOM. But if you also would like to add a remove button to every li, the complexity increases as well. So let's add a button next to the 1, 2, 3, 4 and allow clicking that button and make that remove that specific to-do list item from the list. So to do that, we would also create another element, remove button. All right. Remove button is so now we will create another button that we will be using inside the new item. So remove button to on click. So when the button is clicked, we need to do something else. So let's first console log and see if it works correctly. So we could say remove button clicked, and also add the remove button to the child. So new item dot append child, remove button, new item dot. So another thing we need to do here is, since there's two elements inside new item, we need to add a span. So we're going to create a span now. And add this text to the span. So span dot text content equals text, and then add the span as well, and then remove this. So hopefully, if I save that and click plus, I see a button right here. Clicking on the button, it just says remove button clicked. Let's add text to the remove button. So we could do remove button dot text content equals minus. So we have a plus button, so we could say do homework and add a plus, and also have a negative button that removes the element from the list. So the last thing we need to hook up is actually getting rid of this from the list. And for that, we would need to implement our onClick function. As we can see, it already prints remove button clicked when we click it. So we just have to figure out what element to remove from the DOM. And in this case, we just have to remove new item, so we can use the same reference. So we do new item dot parent. So this is similar to how you would remove an item from a tree, because a DOM is a tree as well. In a tree, if you want to remove a child with a reference to the child, you would get a reference to the parent and then tell the parent to remove the child. And that's what we're doing here as well. So because you want to remove new item, we would get the parent element of new item, which is root in this case, and then remove the child, remove itself. So let's see if this works. And clicking this will remove the item. So cool, we have a basic to-do list item to-do list functionality implemented. So I could add homework, eggs, food, and when I'm done with them, I could click the remove button. So this application is very simple. It's just one screen and there's like a few elements. So, but if you go to a website like codepen.io, you can imagine how hard it would be to add all these different buttons and all the different logic, encode it in simple JavaScript. You can see that this code can really quickly get really hairy and really complicated. So thanks, Calvin. So to make this easier and for larger applications, let's look at how we can do this in React land, and we can see how much more simple it is and how much more React does for us. So I'm going to open codepen.io and create another codepen, and then we can do the same thing in React. So firstly, in this code base, all our code is directly run in the browser. So the HTML is what is running in here. The JavaScript is running directly. In React, we need a few other special things to get it working correctly. So we can go under settings and add those things. So we can add the libraries that we need. So for example, we need a preprocessor, let's call it Babel. And the key important thing is it says Babel includes JSS processing. So what this means is the JavaScript that we will be writing will not be run directly in the browser, but will go through Babel, which does some magic stuff to the code and rewrites it that in a way that the browser understands. Secondly, we're going to add React and React DOM, the two libraries that we'll be using. CodePen is nice in that it lets you import these libraries directly, and so we don't have to worry about like adding npm or node or anything like that and worrying about that. So we're going to search for React and add React 17 and React DOM as well, which is we're going to be using that as well. So we're adding the two libraries and saving and close, and both those libraries should now be inside. So as you can see, the difference between this one and this one is just plain JS, and this one is JS Babel. So cool. So in the HTML side, things are going to be much simpler. So we're just going to create one div and call it root, and that's all we need. All the logic, all the other element handling will be done now in React. So previously, to add an element to the DOM, we would use document dot add child, right, append child. So we've used this function. In React land, there's a slightly different way to do it, and that's what we use React DOM for. So we would use React DOM dot render and then into the root. So we get cool. Let's organize that. I'm leaving the first parameter blank intentionally so we can get to that in a bit. But essentially, I'm telling React DOM that all the things that we're going to write in React, we want to go under root. And so that's what we're getting a reference to that element and then passing it into React DOM. So React DOM knows where to put it. So let's say we also have another div in here, and that's root 2. All the information from React will go into root instead. So let's figure out what to put in here. So here's where all our application logic would go. So for that, we're first going to create a React component. And a React component is an abstraction over an HTML element, essentially, which is a good way to think about it, in that it behaves similarly in that there are ways you can you can also have divs and spans, but you can also encode logic and application logic and state and props, which are used in like large applications. So we're going to create a component and call it to-do list. So So I'm creating a function, creating an anonymous arrow function, and assigning it to the variable to-do list. And this function will return a funky thing called JSX. And JSX looks very similar to HTML, except one key difference: it can run JavaScript inside. So I'm going to return a div just like we did before. And inside that div, we're going to have h1. Cool. And then I'm going to render this to-do list variable in React DOM.render. So I'm going to pass that into React DOM.render, and let's see what happens. And it appears on the side. So the interesting thing to note, in our HTML, when the program first loads, there's just a root element. So if we remove the Babel, if we remove the JS and wait for it to load, there's only a root and it should go away. But as soon as the browser loads the page, it's also going to load the scripts associated with the HTML. And when that happens, this code is run. And this code adds this to-do list component to the root, and which will be this element. And that's why we see h1 to-do list inside the browser. So the next steps are, let's add the interactivity and let's add the logic back. So for that, let's add the button and the input first. So we're going to add the input, and we're going to have the button. And we're going to pass in the placeholder as before, so the user knows what to do with it. Cook eggs. Give me some of this. Cool. And we're also going to add a button and add a value to it, so we know that you need to click that to add something to the to-do list. So do a plus. Cool. Awesome. So we have a very similar looking to-do list. So already notice how in this code, it's very hard to read what is going on if you didn't have the HTML. And here it's very clear that the structure of the application of this component is going to be a div with an h1 input and a button inside. So to add the other components, to add the list items, we're going to make a separate component. So we're going to also make a component for the to-do list item itself. So we're going to do const to-do list item equals, and we do similar things. We create a function that returns a value. And this also returns JSX, and it looks very similar to HTML. So we're going to create a div, and we're going to pass in a prop to it. So components take in stuff that are passed into it. And so, for example, if we want to add a to-do list item to the to-do list, we could just put it in here. To-do list item. Cool. So we now have one element in the list of to-do items. And the way it works is React renders the to-do list component in the DOM and in the root element, and React recursively computes what components should be entered. So first, the to-do list element is rendered. So it starts with this div, it adds a div to the child of the root, and then adds an h1, which we see right here, then adds the to-do list item, which is by furniture, and then adds the input on the button, and then closes the div. But in here, this is not a normal web component, and the way React knows whether should be an h1 or a special component is the first letter is capitalized. And this is a standard. So if I change this to a small t, this won't show up because it'll be rendered as a to-do list item, which does not have any meaning in the context of the DOM. So as you can see, React has decided to create a to-do list item in the HTML that the browser does not know how to handle. When we capitalize it, though, when the JSX is transpiled, which we'll go with that later, it looks up what that component is, and then returns whatever value there is. And in this case, we're passing in arguments. So we are passing in cook eggs to to-do list item. So we're passing in buy furniture to the list item. So that gets rendered in here. So next steps, we have to figure out how to hook up the input and the button to this. So let's look into how that is done. So the most important part about React is the functions are pure. So what that means is that when this function runs, there's no side effects done to the DOM. In here, you see that every time the button.onClick method is called, the DOM is modified in several ways. So there's an element that's created, there's like buttons that are created, there's children that are removed, and children that are also being appended. In React, none of that is happening, and that is a major cause of why things are much more clean in React land. For example, if we pass in different props to the to-do list item, so we could add like have another buy furniture. It just renders it without having to figure out what the difference should be. So let's add state to this so that we know what the current status of the application is. And in React, you use a function called useState. Right. So if you're not familiar with the syntax, JavaScript lets you destructure arrays in this way. So for example, let's say you had an array that was 1, 2, 3, 4, and 5. You can directly assign that to 4 different variables by passing in, setting the values like this. And so A would be 1, B would be 3, C would be 4, and D would be 5. And this is just a quick way of doing setting this as a variable and then getting the first and the second element setting to different values. So we're starting off, the state is empty. So when the application first loads, let's have no to-do list items. For the purpose of this demo though, let's add one item so we know if it works correctly. Win hack Duke. Cool. And so now items is a list of to-do list items that you have to do. And now we have to get the items and then tell React what to do with them. So I'm going to get rid of the items that I already added. And since items is a list, let's console log and make sure that it is the case. So we see that the items is Win hack Duke. So for each item, we want to render a list element inside this div. So let's add that. Let's add a UL so the list knows where it starts and ends. All right, within the UL, we're going to create different list elements. So so far, this piece of code is called is run directly. So it's transpiled into React.create elements. So what that means is if I copy paste this code into the JavaScript console and try to run it directly in the browser, JavaScript just go crazy. JavaScript's like, why is this like lesser than sign symbol like before the div? Like what is lesser than D? I don't know what any of this means. But we're still able to run this JavaScript in here. And the reason why that is possible is that we're using Babel. And what Babel does is it takes this code and changes it into a form that browsers can understand. And we can see how this works by going to Babel. So let's see. Cool. So just setting this. So this code that is run, that we wrote in CodePen is going through Babel, which is a transpiler. And what a transpiler does is it takes a piece of code and converts it into another piece of code that maybe a different kind of computer or a different kind of compiler can understand. And what is being transpiled here is JavaScript that is React friendly into JavaScript that is browser friendly. And as you can see on the left side is a bit more human friendly to write, but unfortunately browsers don't support this, so we have to use tools like this. So in this case, let's look at the first to-do list item. We can actually get rid of this. The to-do list item is being converted into a react.createElement call. So when we call this function, it returns whatever the react.createElement returns with the kind of tag that we use. So in this case, we use an li. So li is being created through React. And we're also passing in the text, which is, this is the content of the child. So if we put the code back in, we can see that to-do list all calls react.createElement on to-do list item as well. So for example, the parent div is being created here. So it returns a react.createElement call with the parent div, and then it returns the children of that in order. So the first child is an h1, which is right here. And the h1 has a content to-do list, which is passed in here as well. Similarly, there's an empty ul, which is why there's a null here. And then there's also an input and a button. And react.render is also transpiled. So the to-do list that I added here is changed to react.createElement. So if I copy paste this code into the console, it still won't work because it does not know what React is, but it's more friendly to the browser. So React is not defined, but it's still able to parse all the JavaScript. So back to this. So and this is why we need Babel, because it's much more easy to write React in this form in JSX. We could also use the create element calls directly, but as you can tell, it's much more easy to parse this and keep code more readable in this way. So let's figure out how to get the items which are in the state into the DOM. So we're going to loop over the items and change them into to-do list items. So firstly, if we do console.log items, it should just say console.log items. And this is because the code that is written in here is interpreted as HTML directly and is put in the DOM directly. So to tell the transpiler that this is not just text that you want to put in the DOM, but we want to evaluate it, we want to put it in curly braces. So in this case, we can evaluate JavaScript here. So we could do 1 + 1, and it would say 2. And instead of that, in this case, we want a list of to-do list items. So we're going to take items, and we're going to convert it into a list of to-do list items. And the way you do that is a map. And for those of you who aren't familiar with map, is it takes an array and runs a function, the same function on each element of the array, and returns the value in a separate list of the same size. So we're going to take items, and we're going to map every item into a different form. So we're going to pass it in a function. Sure. I just missed a question. So it looks like Will's wondering what we had to do to set up the file in CodePen. So let's do that again. So under settings, I'm going to JavaScript right here. And there's two things we need to do. One, we need to add Babel. So if we have none, it means that the code is run directly. So we're going to change it to Babel, which is what we looked at on the different tab. And two, we're going to add React and React DOM. So I'm going to already get rid of these and add them back. This lets you add external scripts to it. So I'm going to search for React. And then let's add the first one and React DOM as well. So both these libraries are now added to this environment so we can use them. So I'm going to save and close. And hopefully that answers your question, Will. And we're going to continue. So this is why we're able to access React DOM in the JS file, because we imported it earlier. Cool. So we're going to map the items into to-do list items. So we're going to take a list of items, which we console log here, which is this win hack Duke, and change it into a list of to-do list items. Let's actually copy this, make a variable, and then console log it so we can see what it looks like. To-do list items mapped. And then we can render that in here. Let's console log that as well. Looks like CodePen is having errors. I'm going to refresh. Cool. Oh. Cool. So it first prints items, which is win hack Duke, and also prints the items that we mapped. So in this case, it's a list of objects, and JavaScript does not know how to print this kind of object as of yet. So it prints this weird thing where it says the first element is an object, and there's a key, and there's props, and the props is win hack Duke, which is the prop that we passed in. So now let's figure out the second step, which is how to add things to the list, how to add things to the list, and how to change state. The important thing to note here is whatever is in items is directly reflected in the DOM. So we don't have to manually add or remove elements. We don't have to create elements or append children or remove children as we have to do in the previous code. We can just directly do it in here. So let's first add new elements to items. So when the button is pressed, as before, we add an on-click handler. So we're going to do that here, and we're going to pass in a function. So this function will run every time we click the button. So let's console log and say hi and make sure that works. Get rid of these. Hi. As I press, it says hi. Cool. And so in here, we're going to change the state. And when we first use React.useState, it returns two variables. It returns items and returns set items. What this means is the first variable that is returned is the actual state, the current state of things in the world. In this case, it starts off with win hack Duke. Set items is a way for us to tell React that we want to change the state of items in the world and add or remove something or change the object that is the state. So in the on-click handler, we can set items to a different array. So we can say cook food. And when we press that, for reload, when I press that, it becomes cook food instead because the state of things in the world has changed. And when things in the state change, React knows that the component will have to re-render. And what that means is every time set items is called, items changes, and because items changes, React is intelligent enough to know that the whole DOM will change. So it computes what the difference is between the previously rendered DOM and the current one. And which is why React knows that it has to swap out this li with cook food instead. But in this case, we want to add the new item to the list. So we are going to do that by first adding some more state. Cool. So what I just did is I also I added another variable to the state. So in this case, text is also in state, and text is the current value of whatever is in the input element. So every time text changes, we want to update this value. So every time we type something in here, we want to make sure that the variable text has that value, and that is why I did onChange, added this onChange handler to the input. So what this means is every time something changes in the input, this function is called, and this function sets the text to the value of whatever is in this input. So, and we're also setting the value to text. So we can type text here, and every time we type something, it should print. Basically, what that means is every time we click a button here, the onChange on this input is fired, and onChange fires the set text, which changes the state, and then when state is changed, React knows to re-render the entire element, and when that happens, this console log is called, which is why we see every time we like backspace or add another letter, it prints. Going back, so now we have to set items. So whatever's in the input, we want to add that to the list of items. So we are going to put it in at the front. So we're going to do text and dot items. And if you're not familiar with this syntax, this just means create a new array, make text the first element of that array, and also add all the elements and items to the end of the array. So let's clean this up a little bit. Cool. So say read a book, and plus it should add it to the top of the list. And the reason it's adding to the top of the list is because we're adding it to the front of the list. So if we move it to the end, it should add it to the bottom of the list. So cool. The other thing we want to do, and we did previously, was clear the button that cleared the input. And so we can do that as well by doing set text and with an empty string. So we know that once the plus button is clicked, we want to remove whatever's in the input. So test plus. Cool. So now we have a to-do list that was implemented in two different ways with two versions of programming, two different ways of thinking about how the web works. One is an imperative way. And an imperative way is every time you want to make a change, you tell the browser exactly what to change in the DOM. So you say, I want this element out of here. I want to add another element. I want to add a child to that element, and I want to change this class name or add this text. In declarative land, we don't have to tell the browser exactly what it has to do. All we have to tell it is, based on state, what the UI has to look like. So if there's many elements in the state, we want to add, for every element, add another to-do list item. The other main thing that people like React for is ability to break the components down into different pieces of logic. So for example, in this to-do list item, let's say we wanted to add a feature where we want to change the color of a to-do list item if you want to click it. So let's say if you're done with it, just click a plus, or done with it, click a green button. So what we're going to do now is add an on-click handler to li, and when you click it, it will turn green. So you know that you're done with that item. So for that, we will add a div. Actually, we just do it here. So we can add style, just like you would do inline styles. And you can do background. Cool. It looks bad, but let's actually fix that. Cool. So by default, things are green now, but we have to add state to this. But since the state of clicking an element is local to this to-do list item, we don't need to tell to-do list this component about it at all. So we can localize state to this component and isolate it. So we can break up the logic and make it simple to use. So we're going to add state to this as well. So let's say toggled and set toggled. And what this will do is it remembers whether the item was clicked previously or not. And so we're going to also use react.useState and set toggled to false default. And then if it's toggled, we make it green. Otherwise, we don't set it. So, and we also need a way to set the toggle. So let's do that as well. So add an on change on click. Let's set it to the opposite of what it is currently so we can toggle it. Cool. So hopefully when you click it, it should turn to 1/2 Duke, so we know that it's done, or we'll click it again and make it go away. So essentially, we are also adding some state here, and the state is completely isolated to this component, so it never leaks out. This allows us to like keep logic in one place and not have to worry about it in the to-do-list component. In imperative land, this would have been much more annoying because the state would be all over the place and hard to isolate. And the great thing about React is it allows us to break it down. Hopefully this has been helpful for y'all as you build over this weekend. And feel free to ask me any questions. Looks like Michael has a question. Cool. So what does the ... syntax refer to? Let's go over that. So I'm going to open the console and we can run, if you're not familiar with JavaScript or the browser, if you click inspect, you can open the console. In the console, you can run JavaScript. So let's start to explore what this means. So let's say we have an array A, and it's 1, 2, 3, 4, and 5. So and let's say we want to make another array, but we want to add 0 to the front of A. So usually what you would do is create an array, say B equals 0, then for I const I in A. Cool. So you would loop through this and then add every element in A to B. Instead, you can just do ... A, and that spreads A. So it removes the, you can also imagine as it removes the parentheses around A into B. So we could also do ... B, and also like 1, 2, 3, 4. So this array would be all the elements of A that were spread out. So it would just like puts it in here. And then all the elements of B that's here. And then we also add 1, 2, 3, 4 to the end. So hopefully that explains what our spread does. Going back to questions. What does the keyword target refer to? Okay, so in this case, in an on change, we want to set state of what the value within the input is every time it changes, right? So for example, in this input, let's go back here. In this input, every time something changes, we want to, let's say we want a console log so we know something has changed. Console.log, something has changed. Cool, clear the console. Then as I type, it should tell me if something has changed for backspace. If I do anything in here, it should say something has changed, right? And so the onChange handler gives us one piece of information that we can use to guess what has changed, and that is the event itself. So let's log the event and see if there's anything useful in the event that we can use. So okay, it looks like this log didn't work, but we can use the browser console instead. Cool. So this is the event that was passed down on change. And in the event, it tells us what element changed. So we can get a target. So target is the reference to the input itself. So as you can see, if you go back to the console, this event is logged in the console, and in the event there are all these keys, and the event is just an object. There's it's like a hash map. So there's all these keys, and in these keys, there is something called target, and that target is a reference to the input itself. And from the target, we can get the value. So every time it changes, we want to know, all we want to know is what is the value of the input. And so when the onChain is called, we get a reference to that input by doing e.target, which is the input itself, and then do dot value, just like how we did got dot value over here when we did previously, input dot value, which is here. So we get the text by getting a reference to input. In this case, we get the reference to input by doing e.target instead. Also, another question is, can you explain again the idea behind state and why it's useful? A little confused on what you mean by isolating the logic. Awesome. Okay. So state is the current state of things in the world. So for example, let's say you open a website for the first time. So let's say you just sign up for Facebook or something, and you click the like button on someone's post. Now the state of that post has to be updated to say that Michael also liked that post. And so so that's how that's what I mean when I say it's the state of the world. In this case, state is what is the memory of the browser hold when we edit this to-do list. So let's say I add like a few items. So I add 1, 2, 3, and 4. State in this case is all the 1, 2, 3, and 4 of what the application is currently holding. The thing with large applications, and for example, let's take CodePen as an example. State of this current browser tab is a lot of things. So for example, there's HTML state, there's state in CSS, which is empty, there's state in JavaScript, there's also state in the console. And it has to remember all these things in the in browser memory, so it knows how to render these things and how to change things around when things change. So the reason why React is so nice is that, let's say if we try to implement CodePen itself with vanilla JavaScript, we would have to maintain state somehow and remember, have some sort of a global hash map, maybe of what the value of the HTML input is, what the value of the CSS is, what the value of JS is, and change it accordingly, change the DOM accordingly. In React, the nice thing is we can make a component just for this input. And then we can reuse that component 3 times. So we could use it, add a prop to it for HTML, add a prop to it for CSS, add a prop to it for JS, and then encapsulate state within that component. So in the case of the current one, we encapsulate state within to-do list item. We encapsulate the toggle state, so we don't have to create a global array of a list of every item and then whether it was toggled or not, because it's stuck in here and doesn't leak out. Hopefully that helps. Looks like I'm almost done with time, so I can take one last question if people have any, but thanks for coming, y'all. Awesome. What is your favorite thing about React? This is Calvin. So I actually like it because I don't really know how to code without it. Cool. I'll be around. I'll be sticking around for the next like 30 minutes or so in the Discord. So if anyone wants help, feel free to hit me up. So Sam asks, do you prefer React over other frameworks like Gatsby and Angular and Flutter? So Angular, for example, uses a different paradigm. It uses something called the model view controller. And it is a different way of thinking about how UI works. But Angular is still more clunky and it's a little bit older than React. And a lot more developers prefer React because it's much more simple. Flutter is similar as well, very similar to React. Flutter actually came out more recently. Flutter, for those of you who don't know, is a cross-platform like library that you can use to make apps for iOS, Android, and they're also working on a beta for Mac, and I think for Windows as well. There's plenty of great resources online about the comparison between React and other frameworks. There's Another popular one is Vue. I'm sure you can find great resources on what the pros and cons for each are. React has the largest community and of developers and libraries, so I like that as well about React. Awesome. I'll be hanging out in somewhere in a voice channel. Well, also feel free to DM me. I am RAHL on the Discord. All right, I'm tuning out. See y'all.